What are simultaneous equations, and when do we need to use them? Consider these two equations. Both these equations have only one variable in them, x, and the value of x can be determined without the need of any other equations. Now, consider the third equation. It has three variables, x, y, z. It is impossible to solve for x without knowing the values of y and z, and the same is also true for solving for the other two variables. If you have one equation, you can solve for one and only one unknown, but if an equation has two or more variables, then it is impossible to solve for all variables with just one equation. That's where simultaneous equations help. You need one equation to solve for each variable. These equations are called simultaneous equations because they are all valid for the values of the variables involved, and we use all the equations together to solve for the values of each of the variables. Remember, one variable, one equation. A typical example given to show the use of simultaneous equations is: Alex is 20 years older than Natasha. 5 years from now, he will be twice as old as her. How old are they today? Let A be Alex's age and N be Natasha's age. Then the equations we get from the information given is: A equals N plus 20. Alex is 20 years older than Natasha, and A plus 5 is equal to 2 times N plus 5. 5 years from now, Alex, who is now 5 years older, is 2 times as old as Natasha, who is also 5 years older. Label these equations 1 and 2. Equation 2 can be rewritten as shown. From equation 1, we have A equals N plus 20, so we substitute A with N plus 20. Subtract N from both sides. Flip the equation, and then subtract 10 from both sides as shown. This gives us the value of N, Natasha's age. From equation 1, we have A equals N plus 20, and we solve for A, Alex's age. So Alex is 35 years old and Natasha is 15 years old. To check whether this answer is correct, plug in the values in both equations to verify that both equations are correct.